So we have three parts to this problem. It's about matrices and using them to solve systems of linear equations. This is the biggest, for me, this is the biggest reason to use matrices. Because solving, A, you would probably solve using what algebraically? What are your three ways you can usually solve using substitution, elimination, or graphing? So you could solve that using either of those methods algebraically. Okay, and that'll work just fine. You don't need matrices necessarily. For B, though, you can't graph that on a calculator. Okay, even a TI-89 will graph that, but you can't find intersection points. Same with C. Okay, so you have to use elimination or substitution, which can be take a half a page for each of those. So I think matrices are the best way to solve these. And realistically, once you know how to do it on a calculator, it's pretty straightforward. Okay, and it's probably easier than the algebra methods. So let's look at A. What I'm going to do here is I'm going to set up probably only B on a calculator. I'll show how you'd set up the matrices, and then B is the only one we'll actually calculate. So for A, you'd have a 2 by 2 matrix, and this is what you have to do on a test to show, like our quiz. Okay, so what would be your 2 by 2 matrix for the left side of A?
It would be 3 and 4.
3. What goes here? 1. And below the 3? 4. And 3. Okay? So you just make sure that you have all of your variables in order, x, y. So these are my x's, and these are my y's. This is equation 1, equation 2. Okay? Now what you're setting up is if you multiply that by the 2 by 1 matrix x, y, it equals a 2 by 1 matrix 11, negative 7. All right? Now what we're actually doing here is we're taking this matrix A, by our variable matrix, which was called x, and that equals our matrix B. So to actually solve for x and y, what we're going to do is we're going to take the inverse matrix of A times B. And the calculator will allow us to do that. So okay, we entered that in a calculator, and JC said she got the matrix 8, negative 14, negative 13. And again on B, I'll show you how to do that in a calculator.
Why is it A, negative 1?
Because to solve this, you have to do the inverse. It's like taking this. If we have cosine x equals a number, right? To solve for x, you have to do inverse cosine of that, right? Same idea here. We're doing the inverse matrix of that. And all that is plugging into a calculator.
Would B be would matrix C?
Okay, let's look at matrix B. What size would that matrix be? 3 by 3. And the reason is we have 3 variables and 3 equations. So we want to make sure we go in x, y, z order. Because we're going to multiply by x, y, z. So what would the top row be? 5, 2, 1. What would the second row be? 1, negative 4, negative 3. We're just taking those coefficients. What would the last row be? Make sure that if we don't have, like they gave us a nice hint here that there's no y. They put a little blank there on the test. There might not be that. Just make sure that you have your x, y's, and z's in order. Okay? And that's going to equal your 3 by 1 matrix, which is 9, 1, negative 2. So now the idea is if we can take and we plug in these two matrices right here. Okay, again, this is being A. and that's B. We call this matrix C X, but we don't need to plug that in the calculator as we're trying to solve. So if we plug in this as matrix C A in a calculator, that is matrix C B in a calculator, okay? And then we call that, and then we just solve the calculator A inverse times B. We'll get our answer. Again, here are the pictures of the calculator screens for the matrices. If for some reason you don't remember how to do that, if you go to the website and the class website and go to the resources, there is a link that says graphing calculator tools or something like that. And if you do go to that, it has all the graphing calculator stuff. There's a thing that says matrices. I believe it's under Algebra 2. Okay? So your answer here would be, and make sure it's on a test, your answer is x equals 1.8, and you can do 1.80, y equals negative 0.439, and z equals 0.85. We could do 854. I know I did different decimals there. All right, questions there?